So in this video, we're going to use RStudio to perform and interpret a two-way mixed ANOVA. Now, in a previous video, I talked about how a two-way ANOVA is used to determine whether or not there is a significant interaction between two independent variables on the dependent variable. Well, in a two-way mixed ANOVA, one of those independent variables is time, and the question we typically want to answer with a two-way mixed ANOVA is, do two or more groups change differently over time or over multiple trials? If you're a clinician, if you're a PT, an athletic trainer, a strength coach, or PA, you're working with patients on a normal basis, you have these interventions that you know are effective. You have a diet plan that you know would have someone's percentage of body fat to go down over time. Well, these interventions that we use in practice is largely based on evidence that's provided by research studies that use what's called a randomized control trial, where multiple groups are followed over time to determine the changes that the intervention or interventions have on these participants on multiple time. And you think about it, these interventions take time for them to materialize, the changes do, right? You have someone on a diet plan and we have to, wait months before we can determine how effective that diet plan is. Or if you're working with a new training regimen, a neuromuscular training regimen, that may take weeks, right? 6 to 8 weeks. So the most commonly used research design for these studies that provide these evidence is an RCT. It is a randomized control trial. In fact, the evidence, the level of evidence provided by these RCTs is considered to be one of the strongest levels of evidence in research. So the statistical design on which these RCTs are based is a two-way mixed ANOVA. And one of the independent variables is group, right? This is the intervention. So that could be, a low intensity exercise group, a HIIT group, high intensity interval training, and a control group. And you wanted to monitor them over a 6-month period. I'm just going to use this as an example. And we tested them for cholesterol level for pre, mid, and post. So this is at time 0, 3 months after the intervention, or into the intervention, and then 6 months post intervention. So it's a pretty simple research question here. We want to know, is there a difference in cholesterol concentration between the three groups over time? So we're going to run this two-way mixed ANOVA using RStudio. Now, before we move into RStudio, another name, I should say, or description of a two-way mixed ANOVA is what's called an analysis of variance with repeated measures, and it's typically described by this 3x3 RM ANOVA. That means 3x3 repeated measures ANOVA. The 3x3 automatically tells you it's two independent variables. The three levels correspond to the three groups, control, low, and high, and the other three corresponds to the time points, pre, mid, and post. So we're going to run this 3x3 repeated measure ANOVA using RStudio. Okay, so now I have the markdown file. I already wrote the markdown file in RStudio, so I'm just going to go over separate chunks of code in order to describe how we're doing this two-way mixed ANOVA. So the first thing I need to do is import that data. So the data that we're using is the cholesterol data. Remember, we're comparing cholesterol levels between three groups of training intensity over time, right? Pre, mid, and post within a 6-month period. So I have the CSV file here. I'm going to go ahead and import that data set. And it's doing its thing, it's previewing. Enter that there. Just to kind of show you real quick how this looks. This X1, that's just simply the ID of the participants in the study or in the sample. These are the groups. 0 is control, 1 is the low intensity group, and number 2 is the high intensity group. These are the cholesterol concentration at the pre, mid, and post points. So I'm going to make sure I've got my tidyverse package loaded. I'm going to read in that CSV data into this data frame or data vector called DAT, as shown here. Awesome. I want to double check the names. This is that code 4344. Good. So X1, group, pre, mid, and post. If you're in my research methods class, Ken 6005, you can download this markdown file along with the data set and follow along if you wish. So I can explain the two-way mixed ANOVA a lot clearer, I should say, in RStudio. Okay, so I'm going to run this line of code. The lines 50 to 71 does some conversion in the code. In the data set itself. If you watch my previous video, I mentioned that in Anova, in RStudio, is performed on the data set in long form. The original data set is in what's called wide form, in which each one of the cholesterol concentration at the pre, mid, and post time points has its own column. But we need to put everything in the long form so that there is a column specifically just for time. Remember, time is a factor here. That's the within subjects factor that we want to use in order to determine the interaction between time and group. So that's what these lines of code does. So I'm going to go ahead and run this chunk. Good. So I'm going to go down to console here, and I am going to type in view. See how that looks. Cool. So that's the cholesterol data. I should have done view DAT long. Sorry about that. There we go. So this is the same set of code, but now I've converted the data set from wide format to long format. Notice that you have one column just for all of the cholesterol concentration. You have one column for all the groups. 0, 1, and 2 represents control, low, and high intensity groups respectively. And then the time points, pre, mid, and post. So that's how the long format looks for this data set. Okay, so let's scroll down. Let's do some summary statistics. That's what this chunk of code is for line 76 to 83. Go ahead and hit play. And these are the summary statistics. That's the average cholesterol concentration for the pre, mid, and post points for group 0. This is a control group. This is the low intensity group, and this is the high intensity group. So you can see their mean and standard deviation cholesterol concentration. So let's take a look at how this looks over time. Let's generate a plot. So this is a cholesterol concentration over time. Okay, so before we run the Anova, let's see if we can interpret what we're seeing in the cholesterol concentration between each of the three groups over time. So look at the pre. This is at time 0. This is before the intervention was actually implemented. So you could see that the three groups are relatively the same. They're pretty close to each other in terms of their mean cholesterol concentration. Now look at 3 months out. Look how group 2, this is the high intensity group, look how the cholesterol concentration significantly drop. For the low intensity group, you could see here that its curve looks very similar to how the control group here. So we know that just by looking at these three curves, or these three plot lines, that the high intensity group had the steepest decline in mean concentration, cholesterol concentration, using this intervention. So we can conclude that, yeah, high intensity exercise is the most effective in reducing someone's cholesterol concentration, but we're only making that conclusion based on this sample. What we want to know is, can we extend these results to the general population? So we have to run this two-way mix analysis of variance. So in an RStudio, the chunk of code, lines 104 to 106, really 105 to 106 here. If you watched any of my other videos on ANOVAs, either on a one-way ANOVA or a two-way ANOVA, the function is the same, AOV. And all I did here is I am assigning the results of this two-way mix ANOVA to this data vector named ANOVA. And if you want to follow along, this is the dependent variable, cholesterol level, that is dependent on the interaction between the two factors, group and time, plus the random noise. This is the error due to what's called the within subjects. This is variance that's unexplained. So we want to know the effects of both these two interaction, the interaction between these two main effects, as well as the error term. And the data set obviously is the DAT underscore long. So I'm going to go ahead and run this. These are the results of the Anova, so let's take a deeper dive. Okay, like other two-way ANOVAs, really just another type of a two-way ANOVA here, we want to know whether or not there's a significant interaction between main effects, between two independent variables on our dependent variable here. In this context, we want to know if there's an interaction between intensity group, right, training group, and time on cholesterol concentration. And the way we answer that question using this two-way ANOVA, using the results of that two-way ANOVA, is this first line right here. And you could see here that for the interaction that the p-value is less than 0 or 0.000, so we know that there is a significant interaction. In other words, there is a less than 0.1% probability of getting an F statistic of 107.8 given that the null hypothesis was true in the population. In other words, if there was no interaction between training group and time, the probability of getting an F statistic of 107.8, remember an F statistic is the ratio between true variance and error variance, and the probability of getting that ratio is less than 0.1%. So we have enough evidence to reject the null hypothesis and conclude that there is a significant interaction between group and time on cholesterol. If you haven't viewed my video on a two-way ANOVA, just to kind of give you heads up on what this F statistic means, the F ratio is dependent on the degrees of freedom due to the interaction itself, and that's calculated off of the time main effect as well as the main effect of the group, as well as the error variance. So this is the residuals, and the degrees of freedom is 84. The ratio between true and error variance is 107.8, and the probability of observing that 107.8 ratio is less than 1%. So we conclude that there is a significant interaction. In other words, cholesterol concentration depends on both group to which these participants belong, as well as time. This is why an RCT provides such high level of evidence on which our clinical practice on these interventions are based. So if you find that there is a significant interaction, we need to do some follow-up tests. And the follow-up test is what's called simple main effects. We want to know whether or not there are differences at each time point between each of this group. So let's just say, in this example, we found that there was a significant interaction. So we'll essentially run 3 separate one-way ANOVAs at each time point. So you already know what a one-way ANOVA, this case is just one independent variable. We're comparing cholesterol concentration between all 3 groups separately at the pre-point, at the midpoint of the 6-month mark, at the 6-month intervention period, and after 6 months. So we'll go over in RStudio and run this real quick. Okay, so in RStudio, the simple main effects for providing or determining the differences in cholesterol concentration between all 3 groups at the pre, mid, and post points is given by this chunk of code here. Actually, I did it for both main effects. This is the main effect of group at each time point, and this is the main effect of time for each group. And I'll go over that in a sec here. So I'm just going to run this code. Right here, it's providing all of the information. I'm going to go ahead and print that. So let's do the pre-summary. And for the midpoint, summary, as well as the post point. And if you look at or the pre, for example. So this is the pre. We want to know, is there a difference in cholesterol concentration between all 3 groups, control, low, and high, at time 0, at baseline? And you can see here p-value is 0.712, so we conclude that there is no difference in cholesterol concentration between all 3 groups. Makes sense, right? Because at that point everyone's the same. You know, we randomly assign the participants to these 3 separate groups, and at time 0 we assume that they're the same, and this ANOVA at the pre-time point confirms that. Now let's take a look at the mid-intervention. This right here, you can see the p-value at the midpoint is 0.006. That means there's a significant difference in cholesterol concentration between the control, low, and high. And so, because there are 3 groups, we have to do a follow-up test of that. I'll come back to that here in a minute. Same thing with the post-intervention. You could see that there is also a p-value less than in this case, less than 0.1, so we conclude that there is a significant difference in cholesterol concentration between all three groups at the post time point. Okay, so as I mentioned earlier, we found that there was a significant interaction between groups and time on cholesterol concentration. So we ran a simple main effects ANOVA, basically ran 3 separate one-way ANOVAs at each time point here. And what we found was that at the pre-time point, there was no statistically significant difference in cholesterol concentration between all three groups, but there was at the midpoint as well as the post-time points. And it makes sense, right? Just by looking at the graph, we could see that the high intensity group had a significantly decline in cholesterol concentration. We also saw that the low intensity group also had somewhat of a decline as compared to the control. And we found that at the mid and the post point that all three of these groups were statistically significantly different in cholesterol concentration. So what do we have to do when we run a one-way ANOVA and it determines that there was a significant difference? We have to do a follow-up test, right? Good old Tukey. So we'll do a Tukey in our studio real quick and determine where those differences lie. Okay, so in our studio, the chunk of code that does the follow-up, in this case the Tukey test, is right here, lines 167 to 170 if you're following along. I'm going to go ahead and run this chunk of code. And these are the pairwise comparisons. So I'm not going to go over each one, but you can tell that, let's see here, let's take a look at the first Tukey. This is the follow-up at the midpoint. There is a statistically significant difference between the high intensity group and the control, as well as between the high and low intensity groups, which makes sense, right? So you can see here the 0.005, 0.043. Now let's take a look at the post. I think we see the same pattern, difference between high and control and high and low. So it confirmed our initial interpretation when we looked at those graphs. Cool. So now the next follow-up test that we should do is the simple mean effect of time, and to determine for each group, is there a significant difference in between the pre, the mid, and post time points. In fact, let's go ahead and look at the graph real quick. So now we're looking at the main effect of time, and we want to determine whether or not there's a difference in cholesterol concentration for each group between pre, mid, and post. So, for example, if I'm looking at the control group, I'll run a repeated measures ANOVA. Remember, it's a repeated measures because it's the same group being tested multiple times, in this case 3 times. And I want to know, is there a difference in cholesterol concentration between the pre, mid, and post time points for the control group. Then I'm going to do the repeated measures ANOVA for the low intensity group, and then do it again for the high intensity group. So repeated measures ANOVA perform or executed 3 times here. So we'll go ahead in our studio, let's take a look at the results. So if you notice, I already ran those simple main effects for both the group and time earlier in lines 128 to 138. When I ran that chunk, I actually did all of them. So all I'm doing now is just printing the results out by using the function summary. So you can click on this. That's the repeated measures ANOVA for the control group, and you can see here that there is a statistical significant difference, or the changes in cholesterol concentration from pre, mid, and post was statistically significant. Let's take a look at the low group. Oops, sorry. Also, that change from the pre, mid, and post was also statistically significant, as well as for the high group here. Okay, so let's take a look again at the results of the simple main effects on time. Remember, we did 3 repeated measures ANOVA for each of the groups, for the control group, for the low intensity group, and the high intensity group, and we found that if for each group there was a statistically significant change in cholesterol concentration from pre, mid, to post, what we want to know is where do those differences lie. So we have to do a follow-up test for these repeated measures ANOVA. And if you watch my previous video on RM ANOVA and repeated measures ANOVA, the way we do a follow-up test is using what's called a pairwise t-test. We can't use something like a Tukey because a Tukey assumes that the groups of comparisons are independent of each other. Obviously, this is not the case because the same group being tested multiple times. So we'll do a corrected or adjusted pairwise t-tests in RStudio. Okay, so these are the pairwise t-tests, doing pairwise comparison of at each level or for each group, and determining whether there are differences between pre and mid, between pre and post, or between mid and post. So if I run this chunk, you could see here that there was a statistically significant difference between pre and post, as well as from mid to post for the control group, right? This is the control group. Now, if I take a look at it for the low intensity group, I see the same thing from pre to post, from mid to post in cholesterol concentration, as well as for the high intensity group. Actually, in the high intense group, there was a statistically difference or change. The changes from pre to mid, from mid to post, and pre to post were all statistically significant. So let me go ahead and clean this up a little bit. I'm going to go ahead and knit so you could see how it all comes together. And again, if you are in my research methods class, you can download this markdown file so you can knit on your own. And I'm going to scroll down to the very end. I went over all of the code as well as the results in detail in this video. So the take-home message here, and I wrote it down. Well, first of all, these are the follow-up tests, the pairwise t-tests I just showed you. I just showed that for the high intensity group, they had each change from pre to mid, mid to post, and pre to post were all statistically significant. And if you are following along, this is how you would summarize the results of your two-way mixed ANOVA in what's called APA format. So I actually have the means as well as the p-values when I'm making the comparisons, and the follow-up tests that we ran. Something like there was a statistically significant interaction between intervention and time on cholesterol concentration, and it provided the F ratio as well as the p-value. And then I went over the individual results of the simple main effects ANOVAs that we ran, both for group as well as time. So remember, to summarize everything up, the main purpose of a two-way mixed ANOVA is to determine whether there's an interaction between factors. If there is, then we run the simple main effects ANOVAs for each of the main effect. Now, there's two main effects as a group, and times you do it for group, right? And you also do it for time. And this is how you summarize the results. So that is a two-way mixed ANOVA.